So today we're going to do extraction, and this is both an active and a passive extraction, meaning we have two compounds that are acid and base, and then a neutral compound. So the acid compound will be extracted with a base. The basic compound will be extracted with an acid. These would be the active extractions. And then the neutral will be just extracted with the passive extraction, just with the dichloromethane. So you will find the mixture ready for you to go. What you need to do is, it already has the mass. You can weigh it to double check. First of all, you weigh the container with the powder, the whole thing. Then you transfer it into a beaker, and then you weigh the empty container. This way, at least you know how much substance is in your beaker, which is how much substance you used to do the extraction. These are not ideal conditions. If you want to really get all the amount in there, you would rinse it with methylene chloride and pour it there and let it dry and then weigh it again. So it's best that you know the exact amount that went into your beaker, and assuming you have equal amounts of each substance. So we have an acid, a base, and a neutral. The first step is we're going to dissolve these three compounds in methylene chloride. And the procedure tells you to put about 20 milliliters of methylene chloride. So I'm going to pour here with my graduated cylinder. And since it's an extraction, it doesn't have to be precise. It's just a solvent. So I have roughly 20 milliliters. I'm pouring it there. And then I need to make sure that all of the substances are completely dissolved in this beaker. Completely dissolved. So you stir it with the stirring rod. Make sure you use the glass part. Even though here I have a rubber policeman, don't put the rubber in there because it might react with the methylene chloride, so you don't want to have another reaction going on. So you stir until all the crystals are completely dissolved in the methylene chloride. Taken a little longer because some of the crystals are a little flaky, they're not powdery. Of course, the surface area, you know, if it's really powdery, it dissolves faster. So once you're done dissolving all your three crystals, all your crystals are completely dissolved, you're going to transfer them into your separatory funnel. So one thing that's super important before you transfer is that make sure that the stopcock is closed position so that the fluid doesn't run down. Another good idea is always to have a beaker underneath your separatory funnel, just in case you have spills. At least the spills are contained into the beaker. Then we're going to use a funnel, even though some of the substance might stick to the funnel. Ideally, I would probably use a glass funnel, not a plastic, because plastic would react with methylene chloride. If not, I prefer to be very careful, and if you can transfer slowly without touching the sides, that would be another good alternative, because you don't want to have any reaction with methylene chloride. So this can be feasible with a beaker because a beaker has a lip. But you know that we still have some substance there. So the best way is to grab a few milliliters of the methylene chloride. I'm going to rinse both my stirring rod with it to make sure all the crystals are in my separatory funnel. And they already start to crystallize again. So, and then you just rinse it And you can do a few rinses 2 or 3 times to make sure all your substance is transferred. Now, my first step is to extract the base. So to extract the base, I'm going to add the acid. And so here's my hydrochloric acid. It's pretty concentrated. So you put about 10 milliliters of the acid in your separatory funnel. So here we go, 10 milliliters, assuming that 10 milliliters is enough to react with all your base. Then you're going to put the stopper and then slowly remove your separatory funnel from the ring. And then the way we do this is very important to follow this. First of all, one finger, on one hand you hold the stopper. You don't want the liquid to come out because you have to tilt it at a 45-degree angle. So you have to make sure that the stopper doesn't come off. And then you're going to swirl like this and vent. And you see there's a little noise. So you just swirl and vent and do it 2 or 3 times. Sometimes over-shaking will create an emulsion and it will make it hard to separate the layers. So don't do it too much, just mix a little bit. And now we're ready. We're going to put it back on the ring, and here a very important step is immediately remove the stopper. What happens if you don't remove it quickly, you're going to have a vacuum suction and it's going to be very hard to take it off afterwards. So as soon as you have to develop that reflex, as soon as you put your separatory funnel on the ring to rest for the layers to separate, make sure you remove the stopper right away. So now we're going to wait until the layers separate. So after this was sitting for a little bit, as you can see, we have 2 layers. So what we need to do is the organic layer needs to go into flask 1. Make sure you label your flask, flask 1, and you slowly transfer it there. This can be very messy lab because the chemicals are colored, and if you spill it on the surface, it will be really hard to remove. So please be very careful when you transfer your liquids. Be patient and be very careful. Okay, so here's my organic layer is ready. This is the aqueous layer, and it's a salt, so you have to put it in a flask that says amine salts. Now what you're going to do again is to put this back in and extract it again with the hydrochloric acid. So two extractions with 10 milliliter each of your hydrochloric acid. Now notice, guys, I always keep some paper towel to make sure that I don't mess up the surface. If you have any spill or any drops, it can be contained on that paper towel. Yeah. So here we go. We're going to do it again. We're going to shake. Again, tilt it, and you vent. Shake, vent, shake, and vent. So you do it 3 times. It's good enough. And then we're going to let it sit and separate. And then we put the 2 layers again. The organic layer will go to flask 1, and the aqueous layer will go into the amine. Okay. So now we have the amine salt, and of course it's not completely pure. It probably has a little bit of the other substances, but what we want to do is make sure we precipitate it, we get back our crystals in the form of a base, because at this point they're in the form of salt because they reacted with the hydrochloric acid. So how do we get them back to their basic form is to add sodium hydroxide. And you have to add the minimum of an equal amount. So since we added, in our case here, I added about 20 milliliters. Now make sure you check on the procedure how much you added for your own sample, because if we change the amount of sample, we have to change also the amount of acids and bases. So I'm going to measure here roughly 20 milliliters of the base. And then we're going to add it to the amine salt container. And you start to see there's like a precipitate which shows that our amine is reforming, but it's gone because we didn't add enough. So we're going to do again and again to make sure we have all the amine precipitate completely. So you see, we see that precipitate here, but I'm not sure all of it is there. So here's what you do. You can use the stirring rod and touch a blue litmus paper, a red litmus paper, and make sure it turns blue. And you can see here it is turning blue. Okay, so it looks like at this point we have our salt in here. So the next step, and it's an exothermic reaction, it's pretty hot. So the next step is you're going to put it in an ice bath, and it will, to precipitate, to crystallize it, then you're going to filter it, vacuum filtration, and then you're going to purify it later. But at this point, we already removed the amine. One of the substance is out of the mixture. So now what do we have here in our organic layer? This is methylene chloride, and what's left in it is benzoic acid and the neutral substance. So the acid, we can extract it by active extraction, meaning if it's an acid, we're going to add the base. So what we're going to do is transfer all the mixture in the separatory funnel, and for the base we added the acid, and here we have an acid, so we're going to add a base. So the base is, of course, sodium hydroxide, and just like we did for the acid, we added 20 ml. For this particular amount, we're going to do the same thing here, 20 ml. 10 the first time, and 10 the second time. If you remember, we did it twice. So you do 2 extractions. The first time, the first one, put 10 ml, and then I'm going to shake it. And vent, and then shake, and vent, and then shake, and vent. Immediately remove the stopper to allow the layers to separate. But in this case, we're not going to put it in the amine salt. It's going to be the carboxylate salts. So here it's the benzoic acid that's a carboxylic acid, so the salt is carboxylate salt. And I have it written with a marker. So the bottom layer is my organic layer, which now should have the neutral substance, and the benzoic acid is now into a form of a benzoate, so it's on the top. That's my aqueous layer. So the aqueous layer will go into this flask. The organic layer, which is in the bottom, will go to flask 1 again. So at this point, we're going to separate the layers. The bottom layer goes to flask 1. And the aqueous layer goes to the carboxylate flask. Then we do it again. Put 10 milliliters of sodium hydroxide. And tilt, shake, and vent 2 or 3 times. Never forget to remove the stopper. So I already see, you can tell that the organic layer is yellow and the aqueous layer is clear. So that means that our neutral substance is yellow. And that's a good indicator. For example, here in the amine salt, we should have the basic compound. There's a tiny bit of yellow I see, which means that I got a little bit of that neutral layer, neutral compound in here. So what does that mean? It means that later we have to purify this substance. So we're collecting here the benzoate salt, the sodium benzoate. And just like we did with the amine salt, we're going to try to get back the benzoic acid in its acidic form. So what do we need to do to get it back into its acidic form? We need to add acid. So here we're going to add hydrochloric acid. And one way to check that I got enough acidity there is with the blue litmus paper that has to turn pink. It looks like I need more. It's best if you go with a pipette here than pour it, because my flask is pretty full. I have to be very careful not to spill the acid. So that's why I go with a pipette. 1 pipette at a time is better than trying to pour directly from the bottle and you spill it. So we don't want to spill any acid. We go slowly. Now it looks like I still don't have enough benzoic acid, so I have to keep adding more acid. Possibly we have some leftover base. Too much base was used. Maybe I didn't have enough benzoic acid, but I added too much base. So you have to keep adding until you see the benzoic acid precipitate. Start to see it's precipitating, but it doesn't look like I have enough of it. So at this point you can go one pipette at a time and check with litmus paper. Here we have some blue litmus paper and it's turning red. So that means we have enough benzoic acid. So what do we need to do with this? Put it in an ice bath. Like we did with the amine salt. So here I have my benzoic acid that is not completely pure, but still we have benzoic acid here, which is my second substance. And my first substance was the amine salt, which is here. And what we're going to have to do is to filter it and then recrystallize it. Now let's go back to our organic layer. So what do we do? So what do we do with the organic layer here? What's left with it is usually like traces of water. So we have to add some drying agent. So here we're adding some drying agent. And I'm pretty sure I have a lot of water in here. So you put your drying agent and you swirl. And you know that you have almost no water when the liquid is kind of clear. It's still yellow, but it's clear. It's not cloudy or anything. So I'm going to add a little bit more, and you let it sit for a few minutes to make sure it absorbs all the leftover water. And then we're going to decant it. So in the meantime, what you have to do is take a dry and clean Erlenmeyer flask and weigh it, and you're going to decant your neutral with the methylene chloride here, and you're going to evaporate the methylene chloride. So that's why you need to weigh this flask, because once you weigh it, after the methylene chloride evaporates, you know exactly how much of your neutral substance. We are ready to decant the neutral substance. So I'm going to just slowly pour the liquid and leave the drying salt in the other flask. And once you decant it, you're going to put it on a hot plate and evaporate the methylene chloride. So but before I did the decantation, I did weigh the empty Erlenmeyer flask. So make sure you weigh it so that after you're done with the evaporation, you can calculate the mass of the neutral substance collected. In the meantime, we put our amine salt and benzoic acid in the ice bath. So here we have some crystals, and we want to do a vacuum filtration. So vacuum filtration, what you need is to prepare this setup. So you need to have a trap here. So this is a trap that is between your filtration flask and the vacuum hose. And then you're going to do the filtration on the Buchner funnel. Now remember, you have to have filter paper here. If you don't put filter paper, your substance will run the bottom. So, and there is a filter paper that has exactly the dimension of the funnel. So you grab one of these and you put it there. It has to fit completely. And then on top of the flask, you have to put these two pieces of rubber. One is a ring and the other one is a cone, because by putting them together, it will secure that vacuum suction. So now that my filter paper is in the funnel, the first step is turn on the vacuum and make sure you read its vac. It's usually the yellow one. And then the vacuum is on. First step is make sure you wet the paper with ice cold water that we put in the ice bath. And why are we wetting the paper? For two reasons. First of all, it opens up the pores in the paper. And the second reason, it allows the filter paper to stick to the funnel so you have no leaks of your substance between the paper and the funnel. And now I can just slowly pour the substance and have my vacuum filtration there. At this point, I can rinse my flask to make sure all the crystals go to the funnel. Then you can rinse one more time. Now the substance is not completely pure. It should be pure benzoic acid, which is a beautiful white crystals. So I'm going to show you how the substance looks like at this point. But before you remove it, don't forget, turn off the vacuum and slowly remove your funnel. Now you see that there is a powder. So here you see our powder is not completely clean. It has a little bit of that yellow substance, which is our unknown. So what you do, guys, is you scrape your substance, your benzoic acid, you scrape it, and we're going to have to recrystallize it. And recrystallization means you're going to purify it and get rid of that neutral substance. So how do you recrystallize it? Just transfer it in a beaker and transfer all the crystals as much as you can in a beaker. Use a scoopula to scoop everything out. So once you have most of your crystals there, so I have my crystals here. Benzoic acid dissolves in hot water, but it dissolves very little in cold water. Whereas the neutral substance, being organic compound, it doesn't dissolve in water at all. So what we're going to do is we're going to add hot water to benzoic acid, and in recrystallization you have to add the minimum amount and let it boil. So I'm going to put it here, and I preheated some DI water. I'm going to pour a little bit, about 5 milliliters would be more than enough, because everybody will have a different amount, so I can't tell you exactly how much you should put, because depending on the amount of crystal you collected. If you didn't collect that many crystals, I would go with 5 milliliters first and let it boil. If it boils and you still see crystals that are not dissolved, add more hot water. So at all times, you should have two things going on here. By the way, this is our methylene chloride evaporating for our neutral. But here, what you should always have is the water being heated, so that if you need more, it's still hot, so you can keep adding. So here, after the benzoic acid recrystallized, dissolved in hot water, you see immediately after I took it off of the plate, it started to crystallize again. So that means that we have perfectly enough liquid to recrystallize it. And at this point, you just put it in the ice bath to make sure it completely crystallized before you filter it. In the meantime, our neutral compound is almost completely, the methylene chloride is almost completely evaporated. So once your flask has absolutely no liquid whatsoever, whether it's on the walls or at the bottom, then you know you have your neutral compound good to go, meaning you just have to weigh it and calculate the percent recovery. So this is almost there. We're going to give it a few more minutes. And as for benzoic acid, you already see that it completely, it was liquid and now it's completely solid, and you can see that it looks a lot different from earlier. There's no more of that yellow, but we still need to filter it, vacuum filtration, and then you leave it in your drawer, you let it dry for the next class time, and then you're going to do a melting point. So before we do that, here's the last step before you do the filtration. You're going to take a clean filter paper and you put the clean filter paper in a nice clean in a nice clean beaker, and you weigh both of them. Why? Because your benzoic acid will be collected here. So you want to make sure by subtracting benzoic acid with all of this minus the beaker and the filter paper, you're going to get the mass of benzoic acid. So first, weigh a 100 milliliter beaker with some filter paper. And once you record that mass, now you're ready to use that filter paper to do vacuum filtration. So, like we did earlier, put the filter paper, start the vacuum, add some cold water, and then filter it. Now the problem is I need to remove it with a scoop. So here's my benzoic acid. I'm going to filter it here and rinse it with ice cold DI water. I think we got all of it over there in our funnel. You let it completely, you want to make sure you have almost no liquid coming out of the funnel, so that tells you you can let it run for a few more minutes just to make sure that it's almost dry. And then once it's almost dry, turn off the vacuum and transfer filter paper and crystals in your beaker, and then you leave it in your locker for the next class period to do a melting point and test and weigh the amount produced. So I can see the crystals are shiny and fluffy. It just shows that we have some good benzoic acid there. It looks kind of clean, and it looks like we have good crystals. Now let's go to the neutral substance. If it doesn't completely dry, there's a good chance you still have some water. So let's hope you don't have that issue, because if you have water, you can still evaporate the water and recuperate your substance. But if you overheat it, it might also sublimate, or you might lose some of that substance. So here, make sure that all your methylene chloride is gone and you only have solid. And you can also leave it in your locker to air dry and then weigh it next time.